Hello, this is a continuation of the review video for your Chapter 3 test in college algebra. And we're starting with problem number 13, which looks like this. 8x cubed plus 6x squared minus 47x minus 45 equals 0. What we're going to do is we're going to do synthetic division starting with -1 to try to find the best integral bounds for the roots of the equation. So I'll write down 8, 6, -47, and -45. And then bring down the 8. -1 times 8 is -8. And then -2, +2, -45, and then +45, and then 0. So that means that -1 is a 0 of it. And then, but I'm not looking for zeros though, I'm looking for a boundary. So we got 0, and that means that this number is not necessarily what we're looking for. So let's try -2. 8, 6, -47, -45. So 8, then -16, -10, +20, -27, +54, and then that would be 9. Now, unfortunately, we still don't get what we're looking for. We're looking for alternate positive and negative signs, but there's 2 negative signs in a row, so this doesn't work. Let's try -3. So 8, 6, -47, -45. If we do it this time, bring down the 8, you'll get -24. Add that up, you'll get -18. Multiply that, you'll get +54. Add those together, you'll get 7. 7 times -3 is -21. And then you'll get -66. Now these are alternating positives and negatives. So -3 is a lower bound. So the lower bound equals -3. That will be the first number that you'll type into the box for the answer. Now, let's try some positive numbers. So let's try +1, +1, +2, and +3. So if I try +1, let me erase these numbers. So if we try +1, we can bring down the 8. 8 times 1 is 8. 6 plus 8 is 14. 14 times 1, and then that would be -40, -33, -33, -78. Those, now we need to get all positive numbers to find the upper bound. So those are not all positives, so let's keep going. So I already brought down the 8. So 2 times 8 is 16. 6 plus 16 is 22. Then you get 44. -3. Oops, I get a negative number. So I know that 2 is not a upper bound because they have to be all positives. And then 3. So 3 times 8 is 24. 30. 90. That would equal 43. And then 3 times 43 is 129. And then if you add that up, it would be 124, be 84. So those are all positives. So the upper bound is equal to +3. So that'll be the second answer to your problem. Okay, now let's try problem number 14. So it says x cubed minus 10x minus 3 equals 0. So first of all, we have to try to use anything that we can think of or guess to try to find one solution to the problem. So looking at Descartes' rule of, actually let's look at the rational zero. So we basically have to think of an answer somehow, but remember, the only possible answers are factors of this constant divided by factors of this constant, which is 1. Well, the only factors of 3 are 1 and 3, or positive 1 or negative 1 and negative 3. So there's only 4 possible answers that could be rational answers. There's also some irrational or imaginary answers as well that could be possible. So let's just start from smallest to largest. So I'm going to start with negative 3. So I'll use synthetic division to divide by negative 3 to see if negative 3 is an answer or not. So it'll be put down the 1 that represents the 1x cubed, then put down a 0 to represent 0x squared because there's no x squared, then put down negative 10 to represent the negative 10x, then put down negative 3. Bring down this 1, multiply it by negative 3 to get negative 3, add up, multiply by negative 3 again to get 9, add up to get negative 1, multiply to get 3, and then you have 0. So negative 3 actually worked. Now remember, after you do synthetic division and you get 0, then it represents that you've lowered the power of the polynomial by 1. So this 1 right here actually represents 1x squared minus 3x is what that represents, and then minus 1. So we can now use the quadratic formula to solve the rest of it. So according to this equation, according to that expression, a equals 1, and b equals negative 3, and c equals negative 1. So if we use the quadratic formula, which is negative b plus or minus the square root of b squared, sorry, I forgot the negative. It's negative b, so it's negative negative 3, plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So if I simplify that, it would be positive 3 plus or minus the square root of 9. Negative 4 times negative 1 is positive 4. Over 2 times 1 is 2. 9 plus 4 is 13, so you get 3 plus or minus square root of 13 over 2. Now when you enter your answers into the computer, there's 3 answers you need. You need this answer, and then you need those. That's actually 2 answers. So you'll have to type into the computer something like this. You'll type negative 3 for the first answer, and then you'll type 3 plus the square root of 13 all over 2. And I would recommend putting your fraction in ahead of time, and then tapping the top and then the bottom, and then comma, and then do another fraction ahead of time. You might need to put a space after the comma, by the way. And then 3 minus the square root of 13 over 2. So those 3 answers written separately like that with commas between them, that's how you'll enter in your answers. All right, perfect. Now let's try number 15. So number 15 says 4x minus 1 cubed and find the x-intercepts. So we'll set the value that's in the factor to 0, and then we'll move the negative 1 to the other side. Then we'll divide by 4 to get x equals 1/4. Now note, this power, it's called a multiplicity. The multiplicity is equal to 3, and that's an odd number, right? If the multiplicity or the power is odd, then the signs of the graph are opposite signs. Odd means opposite signs. Odd means opposite, right? Odd multiplicity means opposite signs. So there's going to be an there's going to be an x-intercept of 1/4 on the graph, like that. And then the signs of the graph are going to be opposites on both, excuse me, on both sides of that point. Okay, so the graph crosses the x-axis at 1/4 and 0, right? So it crosses the x-axis at that point. How do I know that it crosses the x-axis? Because if the signs are opposite, then it could either go from positive to negative, or it could go from negative to positive. Whoops. Or it could go from negative to positive. Either way, if the signs are opposite, it has to cross through the x-axis. So the answer is going to be that it crosses at 1/4 0. Now let's do problem 16. So this is a really great problem. I love these problems like this. So it says x plus 2 squared and x minus 1. So if I look at this equation and set x plus 2 equals to 0, you get x equals -2. But the power of it was 2, which is the multiplicity. So the multiplicity is 2, which is even. And if the multiplicity is even means equal signs. Equal signs. So the signs of the graph are equal to each other on both sides of that x-intercept. Then the second factor doesn't have a power, but that means it has a power of 1. So if you set x minus 1 equal to 0, you'll get x equals 1. And the power is 1, so the multiplicity is 1, and that's odd. So odd means opposite signs. Then you'll have a graph that has x equals -2 and x equals +1. And equal signs, by the way, means that it turns around. It's going to turn around at that point. Opposite signs that we just learned in the last problem means that the graph crosses through. So it crosses through at that point. So now we have to look at one more thing. Do you see this invisible number 1 that's in the front of the problem? That's called the leading coefficient. And if the leading coefficient is positive, then that means that the right side of the graph is positive. But if the leading coefficient is a negative number, that means the right side of the graph is negative. So we know that we have a positive right side. So the right side of our graph is going up because it's positive. Then it crosses through this point, and then it does touch that point, but it does not cross through. It turns back around and goes down. So that's the way the graph looks. So now we ask ourselves, does this graph have any symmetry? In other words, does the right side look the same as the left side? No, it doesn't, because the right side does not turn around. How about, does the top side look the same as the bottom? Or does the right side look the opposite of the left side? None of those are true. So this graph has neither type of symmetry, neither odd symmetry, nor origin symmetry, nor y-axis symmetry. It has no symmetry. And then the second part of it, what are the x-intercepts? So it has two x-intercepts, right? It crosses the x-axis at the x-intercept that's 1, 0, right? So you'll have to look for the answer that says it crosses the x-axis at the x-intercept 1, 0, and then it turns around and touches but does not cross the x-axis. So it does not cross at the point, that point which is -2, 0, right? So you'll have two answers. It crosses at 1, 0, and it does not cross at -2, 0. Now it says, find the behavior as x approaches infinity. So you see in this direction, x is approaching infinity and y is also going up. So y is approaching infinity as well. So as x approaches infinity, y approaches infinity. But at this arrow, you see x is going left. So x is approaching -infinity, and then the y value is going down as well. So the y value is approaching downwards to -infinity. So that's the answer to that. as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches negative infinity. Now let's try problem 17. So problem 17 says, determine whether this limit as x approaches negative infinity of negative 8x, what is that equal to? So you'll basically have negative 8 times negative infinity. Negative times negative is positive, so you have 8 times infinity. But the thing is, you can't actually be bigger than infinity. So 8 times infinity is still equal to infinity, like that. So that's the answer to that one. Now let's try problem number 18. So I really like problems like this. So problem 18 says negative 2, 4x minus 1 squared times x plus 1 cubed. Okay, so first of all, let's look at the insides of those factors. So if I take 4x minus 1 equal to 0, and if I take x plus 1 equal to 0, if I solve this, I'll get 4x equals 1, and then x equals 1/4. If I solve this, I'll get x equals negative 1. But the multiplicity or the power of this is equal to 2, which is even, right? And even means equal signs. And equal signs means that it turns around, right? And then this solution over here, that has a power of 3. So the multiplicity equals 3, which is odd. And odd means opposite signs. Opposite signs. And if there's opposite signs, if there's opposite signs at an x-intercept, then that means that the graph crosses through the x-intercept and then comes out the other side on the opposite side, right? So we're going to draw a graph. So first of all, we have x equals 1/4, which is about right there. And that one, 1/4 turns around, right? And then x equals negative 1 over there. Sorry, hold on. Kind of a weird, there we go. So x equals negative 1, that one right there crosses through. So that x-intercept is going to cross through the graph, through the x-axis. Now we look at the leading number, this number in front. By the way, actually, there is another leading number right there as well. It's 4, which is squared. So the leading coefficient is actually negative 2 combined together with that other number in the front of that one, which is 4, which is squared. So we get negative 2 times 16, which is still negative 32. It doesn't really matter that it's negative 32. The only important thing is that it's negative, right? And if the leading coefficient is negative, then that means you know the right side of the graph is negative. So we know the right side of this graph is going to go downwards, like this. Then, after the right side goes downwards, it's going to touch this point. Then we have to decide, does it cross through that point or does it turn around? Well, it turns around. And then it touches this point. Now, does it go through that point and cross it, or does it turn around again? Well, this point, it will cross. So it crosses through and then goes up. So that's the way that that graph looks. So what you do is you just pick the graph that shows that it shows that it turns around at 1/4 and then crosses through at negative 1, and then you know the answer. So this is just a multiple choice one. So that's that. Now number 19. So this one says negative x cubed minus 5x squared minus 3x plus 9. And we have to sketch a graph of this function. So to do that, we need to find some places where the graph crosses through the x-axis. So what are the factors of 9? Well, 1, 3, and 9, right? So let's just start, well, or positive or negative. Positive or negative, 1, 3, and 9. So I'm just going to start with 1, because I think 9 is probably going to be too big. So start with 1, and you'll get synthetic division, so you'll have -1, -5, -3, and +9. Then bring down the first number, the -1. Now multiply them together. 1 times -1 is -1. Add them up, multiply, add them up, multiply, and add them up, and you get 0. So that means that this is a true solution, because when you plug it in, you get the equation equal to 0. And then remember that after you get 0, then the numbers that are left represent the power of x going down once by 1 power. So this represents -1x squared minus 6x minus 9 equal to 0. Now let me go ahead and take that equation and multiply that by -1, or divide it by -1, either one. If I do that, I'll get a new equation, x squared plus 6x plus 9 equals 0. And then think about the factors that could factor that out. Well, it could be x, and then 3 and 3 multiply to make 9, and 3 plus 3 adds to 6, so it's going to be x plus 3 and x plus 3 equals 0, which reduces down to x plus 3 squared, right? Perfect. So now be careful though, because we actually, when we're graphing it, we don't need to know the answers alone. Like the answer to this would be x equals -3, right? We need to know more than just the answer. We need to also know the power of the answer. So the multiplicity of that is 2. And how about this answer over here? 1. That was x equals to 1, but you see that synthetic division problem only happened once. So the multiplicity of that is just 1. So do you remember what an even multiplicity means? An even multiplicity means that the graph turns, the polynomial graph turns at that point. An odd multiplicity means that the graph of the polynomial crosses the x-axis at that point. Well, now we're ready to draw the graph. So there actually is one more point that might be good to know while we're drawing it. But first, let's put the two x-intercepts on the graph. So if I plot x equals -3, that x-intercept is over there, and that one turns around. And then if I plot x equals 1, that x-intercept is right there, and that one crosses. So if I plot in the x-intercepts, don't you think it'd be a good idea to plot the y-intercept as well? Well, how do you find the y-intercept? You find the y-intercept by just simply plugging in 0 for x. So if I plug in 0 for the x value into the equation, you see I just get 0 minus 0 minus 0 plus 9. So what's 0 minus 0 minus 0 plus 9? It's just 9. So the y-intercept is 0, 9. So that's the y-intercept. Okay, now we need to look at the leading coefficient. Well, the leading coefficient is just a number in the front of the highest power, which is a negative, but the negative really represents -1. So the leading coefficient is -1, and since that's negative, it means the right side of the graph is equal to a negative. So we're going to start on the right side of the graph and making it be negative. Then we're going to touch this point and cross through that point, and then go up to this point, and then come back to that point. Now, when we get to that point, we're going to turn around and go back up. So that's the way that the graph of this looks. Now, of course, the computer might show a little bit different scale, and it's probably going to look a little bit smoother, but this shows all the important details though. So what you'll plot is, yes, excellent. You can plot several different points. For example, you can plot -3, -3, 0. You can plot 0, 9, and you can plot 1, 0. So just make your graph look like that. All right, perfect. And if you need to, you can maybe even plot one more point as well. I'm not sure if you have to. What if you did have to plot another point? Well, you could just plug in any other number, like you could plug in 2 for x, and then if you plugged in 2, you could figure out the value of y And then you could plot that point as well. Okay, so now number 20. So number 20 says x to the fourth minus 73x squared plus 576 is less than 0. And that actually, you don't even have to look at that. That's just there to scare you. So all that matters is the graph. So the graph shows you that at -8 and at -3 and at +3 and at +8 that you have 4x intercepts, right? And then the graph of the problem on number 20 shows you that this part's going up, then this part's going down, then up through here, then going down, then going back up. And you're supposed to solve this problem by just looking at the graph. So think about what the problem says. The problem states that the graph of this function should be less than 0. So it cannot be equal to 0. So let's cross out the x-intercepts because those are not allowed because that's equal to 0. So cross those out. They're not allowed. Now, also, if it's less than 0, that means it's below. So I can shade in green. I can shade the part that's below 0, right? That part and that part, because the graph is underneath the x-axis. But I cannot shade the part that's not less than 0. So I'm going to draw an x through that part and through that part and through that part. So there's only 2 parts that are actually less than 0. And now I'm going to draw a little box around those. You see the left side of that is -8. The right side of that is -3. And the left side of this is 3 and the right side of that's 8. So the way you write your answer is you go -8 to -3 union 3 to 8. And then see those points at the ends. If those points at the ends, if those points are included, you'll do a bracket around the number. But if they're not included, you'll do parentheses. So the points are not included because we had drawn a red X through them. So since they're not included, we'll put parentheses around those numbers. So the solution to this problem is exactly looking like this. Okay, perfect. Now, let's look at problem number 21. Two over x squared plus 2x minus 35. And it says to find the domain. So domain is all the numbers that are allowed in the function. All the x values that are allowed in the function. So let's factor out the bottom and let's find out. So if I factor out the bottom, I'll get 2 parentheses, 2 pairs of parentheses, x times x, and then I need some factors of 35, like 5 times 7. So if I put a +7 and a -5, that times that equals -35, but 7 plus -5 equals 2. So then the answer would be x equals -7 and x equals, okay, so if I set x plus 7 equal to 0, if I set x plus 7 equal to 0, I get x equals -7. And if I set x minus 5 equal to 0, I would get x equals 5. So I've got a question. Is the denominator of the problem allowed to be 0? So in other words, now I've solved this problem and it's equal to 2 over x plus 7 and x minus 5. So if I plug in a -7 for this, if I plug in a -7 for x, I would have a 0 in the denominator. And a 0 in the denominator is not allowed, right? So -7 is the result of the equation, but that's not allowed in the denominator of the problem because it would make the denominator be 0. So -7 is actually not allowed, right? Okay, then how about 5? So 5, x equals 5 is over there. I'm sorry, I wrote 7, not 5. So x equals 5 is over there. And that one is also not allowed because if I plugged in 5 for this x, I would also have 0 in the denominator, which is not allowed. So that number is not allowed. But any other number is allowed, though. So it doesn't matter if it's greater than 0, less than 0, or anything. Any other number is allowed. So that part and that part and that part are allowed. So you see, I can draw arrows at the ends of that, like that, and a parenthesis on that side, and a parenthesis on that side, and that side, and then a parenthesis on that side, and then an arrow on that side. So everything else is allowed, meaning that the solution goes from negative infinity through -7, then a union, and then -7 to 5, parentheses, and then another union, and then from 5 with the parentheses to infinity with another parentheses. So that's the domain of that problem. Perfect. So now let's try problem 22. So problem 22 says you have 3x squared plus 6 over x plus 4. So first of all, we want to find the vertical asymptote. So look at the bottom to find the vertical asymptote. Look at the bottom and find out if there's any value of x that would make the bottom be 0. And if you had x equals -4, then the bottom of the fraction would be 0. So the vertical asymptote is that equation. It's just x equals -4. Now, one common mistake is a lot of people will think they can just put in -4, but you have to put in x equals -4 because it's vertical. So vertical line equation always starts with an x. So x equals -4. Then, how about the horizontal asymptote? So the horizontal asymptote. So we need to compare to see if what the power of the x is in the top. So the numerator. What's the power of x in the numerator is 2. And now what's the power of x in the denominator? Well, there is no power of x in the denominator, so therefore it's there, but there's an x, so there's an invisible power of 1. So the denominator has a power of 1. And the thing is, if the numerator power is bigger than the denominator, then there is no horizontal asymptote. So there is no horizontal asymptote at all. So the answer to the second part is there's no horizontal asymptote. And then your third question says, what's the oblique asymptote? So there's an oblique asymptote if the numerator power minus the denominator power is equal to 1. So the numerator minus the denominator is 2 minus 1 equals 1. So there is an oblique asymptote. And the way you find it is by taking the denominator and dividing it using long division into the numerator. So 3x squared plus 0x plus 6. Now the way you do long division is you really just divide the very first term into the very first term. So you take x divided into 3x squared and you get 3x. Then you have to balance the balance out. You basically have to multiply it back and then subtract everything that was left. So I take the 3x, multiply it back. Now when you multiply it back, you have to do it times both of them. So 3x times x is 3x squared, and then 3x times 4 is positive 12x. So let me write down the steps of long division. So the first step of long division is to divide the first term, right? The second step of long division is to multiply back by both terms, right? The third step of long division, which we're going to do now, is you switch the signs. You switch the signs of the answer that you just got. So I'm going to change this to negative, and I'm going to change this to negative. And then you add. So the fourth step is add. So add those up. Now this part cancels out. 0 plus negative 12x is negative 12x. And then 6 plus nothing is just 6. And then when you do long division, you repeat it again. It's like a brand new division problem. So right here, there's a new division problem. And you're going to start at step 1. So you divide the first term into it. So just take this first x x divided into negative 12x. That leaves you with negative 12. Then go to the second step, multiply the negative 12 back by both terms. So negative 12 times x is negative 12x. Negative 12 times 4 is negative 48. Then do the third step, which is switch the signs. So this becomes positive, this becomes positive, and then you add. So you get this cancels out, and then 6 plus 48 is equal to 54. Now you try to go back to step 1 again, but it's impossible because you see x is an x, and you cannot divide the x into the 54. So that's the remainder, right? Remainder equals 54. And the thing is, the oblique asymptote is like this. The oblique asymptote is y equals the quotient 3x minus 12, and the remainder is not counted because you see the remainder is like 54 over x plus 4, which approaches 0. So the oblique asymptote is just the quotient alone, and you have to put a y in front of it as well. So the equation of the oblique asymptote is y equals 3x minus 12. And so I'll go ahead and make another review video for you. Let's see, actually, I might have time to finish this one real quick. So let's keep going. So problem 23. Negative x over x squared minus 1. First of all, you have to factor out the bottom. So that equals negative x over parentheses, parentheses, x times x minus 1 times positive 1. And then you get that equals, well, that's all actually. So now what you're going to do is find the vertical asymptotes. So to find the vertical asymptotes, you look at the bottom. And the vertical asymptotes would be when the bottom is 0. So if x equals 1, or if x equals negative 1, both of those would be the vertical asymptotes. And in this question, you only need to type in just the numbers of the vertical asymptotes. Okay, now let's find the horizontal asymptote. So to do this, you look back at the original fraction, so the horizontal asymptotes. The numerator of the original problem has a power of x that's equal to 1, right? The denominator of the original problem has a power that's 2. And if the denominator is a greater power than the numerator, then this automatically means that the horizontal asymptote is y equals 0. So your answer to that part of the problem is 0. And then you have to find the x-intercepts. So to find the x-intercepts, you look at the top of the fraction, the x-intercepts. So the top of the fraction is negative x. You set that to 0 and you divide by negative 1 and you get x equals 0. So the x-intercepts are x equals 0. Sorry. Yeah, x equals 0 and y equals 0. Because if you plug in 0 for x, you get 0 for y. So that's the x-intercept. Then you need to find the y-intercept. So to find the y-intercept, you will plug in 0 into the equation, but if you plug 0 into the equation, you'll still get 0, 0. So the y-intercept is 0, 0. And then you have to sketch a graph of the function. So I'm going to take all that information and sketch a graph. So I'm going to erase this. I'm going to draw a graph. So first of all, let's label the vertical asymptotes, which were 1 and negative 1. So there's going to be a vertical asymptote going through both of those points, like that. Then let's label the x-intercept, which is 0, 0, and the y-intercept as well. Then let's label the horizontal asymptote. So that's y equals 0. So the horizontal asymptote is, now don't draw the horizontal asymptote through the middle of the graph, just draw it at the ends of the graph. So the horizontal asymptote is y equals 0 at both ends of the graph. Then we're now going to look at the leading coefficient, which is this negative right there, -1, and then it's also this positive one right there. So you divide them to figure out the leading coefficient of the whole problem. So the leading coefficient of the top divided by the leading coefficient of the bottom is equal to the whole leading coefficient, which equals -1. So the right side of this graph is negative. So the right side of this graph is negative, which is down there, but that's approaching towards the horizontal asymptote. Then on the other side of it, it's approaching towards the vertical asymptote, like that. Then, now we have to look at the powers. So look closely up at this problem right here. What power does the x have? 1. What power do those have? They have 1. All of those are called multiplicities, right? So the multiplicity of this vertical asymptote is 1. The multiplicity of this point is 1. The multiplicity of that vertical asymptote is 1. If they're all 1, that means they all change signs, remember? Because 1 is an odd number, and odd means opposite, right? So they're all going to be opposite signs. So you see this part right here is negative, right? The opposite sign of negative is positive. So this part right there is going to be, sorry, hold on. Whoops. This part right there is going to be positive. So this part over here is going to be positive, and it's going to be going up towards that side. Then it'll touch this point. Now, what's the opposite of positive is negative, right? So this is going to cross through and then go down. Then the opposite of negative is positive, so this part is going to go up, and then it's going to come down and approach towards 0. So the graph of it looks kind of like this. Now, once again, the scale of the graph on the computer could be a lot narrower than this. So what you should just be looking for is a vertical asymptote at 1 and -1. And then you should be looking for the graph to be negative on the right, and then positive, and then cross through 0, and then be negative, and then be positive again. So once you get that multiple choice question clicked, then you're done with that. Okay, now number 24. So this one says 4x squared minus x over x minus 1. Now notice that the power of the numerator is 2, the power of the denominator is 1. And since the numerator minus the denominator equals 1, that means it has an oblique asymptote. So we're going to find the oblique asymptote by dividing the bottom of it into the top of it using long division, right? So divide the first term into the first term, you'll get 4x. Multiply it back by both terms, so you have 4x squared minus 4x. Switch the signs, negative and then positive, and then add it up. So this will be 0, and this will be positive 3x plus 0. And then divide it again. So divide the first term, x into 3x is positive 3. Then multiply back by both, 3x minus 3. Switch the signs, negative and positive, and then add that up. So that's 0, and then 0 plus 3 is 3. But x doesn't go into 3, so the remainder is 3. And the oblique asymptote is y equals 4x plus 3. So we're done with the oblique asymptote. That's that part of the answer. And then the next part of the answer is to find the graph. So the graph should show an oblique asymptote like this. Oh, actually, before I do the graph, I need to factor it out on the top. So x can factor out, leaving you with 4x minus 1. And in the bottom, you have x minus 1. So when you draw the graph of it, you should have an oblique asymptote y equals 4x plus 3, like this. Kind of like this. Going through y equals 4x plus 3, which is a line that's going upwards. And then you should also have a vertical asymptote at x equals 1, right? So at x equals 1, you'll have a vertical asymptote like that. So your graph is going to be going like this. Above here, then going up. And I know it's above because you see the leading coefficient of the problem is positive 4 over positive 1. So it has to be going up. Then on the other side of that asymptote, it's going to be going downwards like this. And the x-intercepts of it are x equals 0. And then 4x minus 1 equals 0 means that x equals positive 1 over 4. So x equals positive 1 over 4, which is right here. And then x equals 0, which is right there. So this part of the graph is going to change to negative, go downwards. Then it's going to cross through this point, then through that point, and then it's going to be negative again, going down towards that asymptote. So that's the way the graph of it looks. Now number 25. The last problem on this chapter test, it says w squared minus w minus 20 over w minus 11 greater than or equal to 0. So this problem is actually a lot easier than it looks. You just simply factor it. So w, and then negative 5 and positive 4, that would work. Then w minus 11 on the bottom, and then greater than or equal to 0. So you see the powers are all 1. So the multiplicity of everything is 1, which is odd. So every single one of these things is going to change signs, right? So you're going to have a number line. Now in the bottom, you get w equals 11, right? But the thing is, you can't have 0 in the bottom, though. So that point is actually not allowed. So I'm going to draw a big red circle through that and an X through it. That point is not allowed. But then you also have w equals 5. That's it. That's equal to 0, which you can't have 0 in the graph in the top, right? So that's a solid point. And then you have w equals negative 4. Because if you take w plus 4 equal to 0, you'll get w equals negative 4. Now, the thing is, do I need to draw a red X through those two solid points or not? Well, look carefully. You see this little thing right there? That means greater than or equal to 0, right? So if it's equal to 0, that's allowed. That's true. So those points that are equal to 0, those are good. So I'm going to cover those up in green. They're good, right? Because you want it to equal 0. Okay, now let me draw out the graph. So if I draw the graph, now what's the leading coefficient of this? It's 1 in front and then 1 in front. 1 over 1 is 1. So the leading coefficient is 1 over 1, which is 1, which is positive. So the leading coefficient is positive, meaning that the right side of the graph is going to be going positive, right? And then every single one of these points changes signs. So that's a positive. Hold on just a second. That side is, whoops, something's wrong. That side's positive, but if it changes signs, then this part will be negative if it changes signs again. Because remember, it's an odd multiplicity, and odd means opposite signs. So this part will be positive, and this part will be negative. Now, which part is greater than 0? Well, we want it to be greater than 0, which means we want it to be positive. So this part is positive, and this part is positive. So the solution to this problem is the parts that I've labeled in green. So what parts did I label in green? Let me erase some space. Oops, I'm sorry. I need to keep that plus there. So the parts that are the solution are the parts that are valid, the ones that are greater than or equal to 0. So it's from negative 4 to 5, as well as it's from negative as, wait. Oh, that looks like negative 11 for some reason. That should say 11, right? It's not negative 11, it's just 11. And then it's negative 4 to 5, and then it's 11. Okay, that green part goes to infinity, so it's from 11 to infinity. Now you see these green circles right here, these are solid, they're included. So those would be brackets, and then another bracket, and then union, but the 11 has an X through it. So the 11 point is not included. So that would be a parenthesis. So the solution to this problem looks like this. Brackets around -4 to 5, and then union, parentheses around 11 to infinity. So that's the last problem on your review for chapter 3. So good luck, and I hope you can all get 100% on these questions.